All right, sprint number 29 reads, Logan has a fair six-sided die labeled with the positive integers from 1 to 6 inclusive. He rolls the die once and records its outcome A. He then replaces it with a 7 minus A sided die with sides labeled A through 6 inclusive. He then rolls the die again, recording a second outcome B and replacing it with a 7 minus B sided die labeled from B through 6 inclusive, and so forth. This continues until Logan rolls a 6 on the die for the first time. Compute the expected number of times he must roll the die before he stops. So, first of all, trying to envision this, if we start from him rolling his original six-sided die and going up, we're really quickly going to get into a lot of cases that we don't really have good ways to track, and we're going to end up bogged down if we try regular casework. So we need to come up with a different way to think about this. One way that might be easiest is if we start by thinking from his last rolls downwards. To make this a little bit easier, let's go ahead and come up with a function e such that for any n in between 1 and 6 inclusive, let e of n be the expected number of rolls of a die with faces n to 6 that Logan will make before he rolls a 6 during his game. So since n stops at 6, let's first think about e of 6. Well, the way we defined it, e of 6 will be the expected number of rolls Logan will have to make in his game of a die with faces from 6 to 6, or essentially how many times he'll have to roll if all of his options are 6. And the only way he can get to at the point where he has a one-sided die labeled with 6 is if he's already rolled a 6 in the past, but specifically the roll right before this case that we're talking about now in the case of e of 6. So the expected number of rolls that he's going to have to make, since he's already made the roll he needed to make, is 0. That's our starting case. Now that we've defined e of 6 as 0, let's think about e of 5. So the expected number of rolls that Logan will make if he's holding a die labeled with two sides 5 and 6. Well, he's going to have to make one roll, right? That's where he started. Or that's where he's starting. He's about to roll his two-sided die, one side saying 5, one side saying 6. So that's where our 1 comes from. And then the result, he's either going to get a 5 or a 6, equal probability. So there's a half chance that he's going to end up rolling a two-sided die with sides 5 and 6, which is also denoted by e of 5 for the expected number of rolls he'll have to make after this roll we're talking about. Or he's going to roll 6, and he's going to then replace his die that he's using right now with a one-sided die labeled with the number 6. But we know that this right here equals 0. So if we simplify, we can just essentially scribble all of this out, leaving us with e of 5 equals 1 plus 1/2 times e of 5. And now that we don't have more than one unknown term, we can solve for e of 5. If we multiply both sides by 2 to get rid of this fraction right here, we get 2 e of 5 equals 2 plus e of 5. Or, simplifying, we get that e of 5 is equal to 2. And now we can continue to work backwards. We know that e of 5 is equal to 2. So now if we look for e of 4, well, if he's rolling a three-sided die with the sides labeled 4, 5, and 6, he's going to have to roll that one time, like we included in our case for e of 5. And then after he's rolled, he's either going to roll a 4, a 5, or a 6, and thus he's going to be rolling either an e of 4 case, an e of 5 case, or an e of 6 case. And once again, we can substitute. We know that this right here, this e of 6 is equal to 0, so we'll just scribble that out. We know that e of 5 is equal to 2. And then to make things easier, we can multiply both sides by 3 to get rid of this fraction here. And we get 3 e of 4 equals 3 plus e of 4 plus 2. Simplifying, we get 2 times e of 4 equals 5. Or e of 4 equals 5 over 2. And we can continue this pattern, continually going down in the value inside our function e of n. So I'm not going to show the steps for each of those because it's just computation. But now that we have that e of 4 equals 5 over 2, we can substitute and find that e of 3 is 17 over 6, e of 2 is 35 over 12, and e of 1, which is where we want to start, which is the answer we're looking for because Logan is starting with a 6-sided die with faces labeled 1 through 6. We get the e of 1 is going to be 1 plus 1/6 times the quantity e of 1 plus e of 2 plus e of 3 plus e of 4 plus e of 5 plus e of 6. And when we substitute and simplify, we find that e of 1 is equal to 197 over 60, which is answer choice D, and we're done. Thank you.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.